Well, hi everybody. How's everybody going? Is someone new? Yeah, it's new faces.
Are you recording?
Yeah, it's still recording.
You became more popular.
Yeah, I became more popular. Well, here for this course, we're gonna see C++. We're gonna show you the basics of how to install it. I hope you all came or see the first part of Python so you can know the basics. I wanted to present you Ariana Savario. She's going to be my co-host. In any questions you may have, you can ask me, you can ask her. Okay? We're going to make this the best as we can because it's going to be a really hard workshop. First of all, I'm going to show you how to install CLion. In this case, if you see, you go to the first link. If you have you ever do you all have the .pdf I sent you before in the group chat? If not, you can search CLion JetBrains student. Okay? Well, not CLion, just JetBrains student. When you get there, you go down here to get free access to all the relevant tools for JetBrains. You click and apply now. And then you're going to fill up this real quickly. Then you're gonna get the email. If you have Visual Studio Code, it's okay too. Okay. In any other case, then we can go back to the PDF I sent you, and then you can go straight to download CLion. Okay, you download it, then you put your account inside the application, and you can program. Okay. If you can do this, it would be great. If not, it's okay. If you want to program in the browser, you can do that. If you want to just write the code, it's okay. If you have Visual Studio, that it's actually kind of easier to install, you can do it. You just search Visual Studio Code, you can install it. Okay, yeah. These two links are if you want to get to know the environment of CLion, but we're gonna center right here in the cheat sheet. We have three cheat sheets. We have the modern C++ cheat sheet, then the basic and the very basic. We're going to use the very basic cheat sheet. For example, you click here. We're gonna go to our GitHub repository and we're gonna get different files that will explain you some basic functions. Let's say we'll go to this one, for example, and here you see with the full documented example of how everything works. So if you want this, you should have this open as a base, because in this specific course, it's not going to be similar as the last one. In this one, I want you also to work with me and with Ariana so we can learn how to search things, how to program without base information. I'm gonna tell you that in my experience, for me taking courses of programming, I have never been in a position that my professor explains everything to me. Okay, so you should learn how to search information, how to search for functions, how to do things. That's why I showed you in the last course the Stack Overflow and GitHub repository examples, so you can search for information. Also, we're going to use in this specific crash course a lot of links of Git for gigs. Okay, that is it's like the Wikipedia for code. Okay, so you can search a little bit in there, some tutorials, anything, because I want you to search everything that you don't know. Please, you don't know something, write it down, write the function down if you don't know something. And before you ask me or ask Ariana, search it yourself. Okay, it's a good practice. You should know how to search information for code. Okay, now we already passed this. I'm gonna show you and explain to you what's an algorithm. As I told you before, we're going to use a gigs for gigs link, and then we're going to see right here what's an algorithm. Okay, please, someone, be my guest. Could someone read the definition? Come on.
It's a set of finite rules or instructions involved in the calculation of other problem-solving operations or a procedure for solving a mathematical problem in finite steps that are related.
Exactly. Have you ever heard about an algorithm? Yeah.
The
What
YouTube algorithm.
Yeah, it's kind of similar, okay? If we see here, we can see an image. We get an input and the algorithm. Set of rules to obtain the expected output.
You can look at that like the function.
Yeah, exactly. An algorithm is kind of as a function. The thing is, it's made to process the input in a specific way that you want it. For this type of input, the input needs to be something less specific based on the algorithm you're given. Okay? We're going to see some algorithms later in this workshop. We're going to see, for example, an algorithm named Dijkstra. In this case, in this specific algorithm, if you give the input a list of just ones, the Dijkstra is going to work incorrectly because it's not made for that specific input, okay? Or it's not going to work as you want. So the output cannot be expected or cannot be traced. That's something really important. If you make an algorithm, you should kind of know what's going to be the output, okay? So for conclusion, we can say that an algorithm is a function for a specific input with a specific output. Here you have some uses of algorithm. We're going to skip this. What is needed for algorithms? Well, nothing important. What are the characteristics of algorithm? Well-defined inputs, as we said before. Well-defined outputs. You need to know what's going to be your output. Clear and ambiguous. Unambiguous. Needs to be clear, okay? You can put anything weird inside your algorithm. Language independent, feasible, finite. This is really important. Most algorithms, well, all of them have to be finite, okay? You can't do anything to the infinite. It's not going to work correctly for you or for your PC. So have that in mind. If you want to look this deeper, I send you the link. This file, you have this link in the PDF I sent you before. Okay. Now, we're going to see some examples. I'm going to explain to you what's the Dijkstra algorithm. We're going to do this quickly, okay? The first one. Okay. Can you see this correctly? Yeah? Okay. We have an A point, okay? An A point. Then we have a B point. Then a C point. Then a D point. Then a A point. Okay? You see the rows, right? All of them have different values. In this case, this one is 4. This one is 2. This one is 1. This one, 3. 3. Yeah. 1, 2. Okay. Now, I know this is a little bit of a mess, okay? But the dictionary algorithm is an algorithm made to find the shortest path to the endpoint. In this case, we know that the endpoint is E, okay? So we want to find the shortest path to E going through all the points, okay? Now, we have the point A, that is 0 because we start in A. The rest are in infinity, okay? So, tell me, what's the shortest path from A? From A, what's the shortest path? The shortest, C, E, right? Okay, so now we can change the values. So now we know B is 4. We know C, it's 2. Then we know E, it's 5. But right now we don't know D. Okay, that's what we got. Now, we have to go to the shortest path, right? So we know that 2 plus 1 is 3 to go to B, right? So if we go to the point A to the point C, we know that the sum of the values is 3 to go to B. So now we know that the shortest route to B is 3, okay? Now, what's less than 3 in this case? Well, if we go to D, we know that now the value, sorry, I write it wrong. This is 6, okay? And this is 7. Okay, I'm sorry. Well, now we know that the shortest route to B is 3. Then we can say that the shortest path to, let's say, C, no, to D is going through A, C, B, then D. So we know that now D is going to be 5 in this case. Okay? Is everyone getting the hang of it? No?
I have no idea what you're
Are
saying.
you adding up the numbers?
Yeah, I'm adding up the numbers.
And trying to give the lowest count?
Exactly.
Why is D not 6? Why can't we go A, B, D?
Because if you see the path, the shortest path is the sum of the values. In this case, A, C is 2, right? C, B is 1. In this case, it's going to be in the point B, the value is going to be 3 because it's going to be 2, 1. Okay?
Okay, I see.
Instead of 4, that is A, C, A, B. In this case, A, C, 2, C, B, 3, then B, D, 5. Okay, that's why the value of D is 5. In that case, you just need to do the math and then go to the visit nodes. Each specific point is a node. I think I'm gonna show you a video because I think it's better because I don't believe you're understanding me correctly.
Last, okay, sorry for doubting you again, but isn't E6, can we just go like by the path we took 3 and then go diagonally from B to E? That'll take 3, right?
Yeah,
So E6.
the thing is that the process needs to be done from the less value points, okay? So I think I'm not explaining myself, so I'm going to show you. It's better. Yeah, I have a video.
No, I meant like maybe she had some.
Oh, can you explain it? Do you know the Dijkstra?
Okay, just hold on, let's see. What's the final?
Oh, the final answer is A, C, D. The thing is, I believe it's better, the video, because it's 3 minutes.
So the objective is getting from A to E. That's clear, right? Right. Okay, so A has two paths. It can go to B, it can go to C. So if we go to B directly, we get a value of 4. But what's other way to get to B from A? Going to C and then going to C and going to B. So in this case, going directly A to B is equal to 4. A to C to B, that's gonna be 3. Okay, that's that first path. You got A, you got B, sorry. C, and then we got B. Okay, now B. The possible paths from B are to C, to D, and directly to E. If we go to B first, to D first, we're gonna have to go to E, because that's the final objective. So it's gonna take 2 plus 1, right? So this path from here is gonna take 3. If we choose to go to C, then we're gonna have to go to E at the end. So B to C is 3, and C to E is 5. Okay, so we get 5 plus 3. So this path, that is B to C to E, is 8. And the last one, B to E, that's on 3. It's easy. Got B, E. Okay, so what's better? A, 3. For this.
So there's 2 possible steps, right?
Two possible.
So here's my question for that. If we're taking into consideration the value of each path, right? And you want to have the sum of the paths that add up to the least number or the smallest number possible, right? Do the jumps or like the stations that you're going to end up also come into consideration? Because for example, you could go A, C, B, E, right? And you get 6. Or you could go A, C, B, D, E, and you could still get 6. But you're taking one more step going through D. Does that have an effect, or do both have the same value at the end because they both add up to 6?
The thing is here, you need to understand that the Dijkstra algorithm, is the shortest path to all nodes, okay? So you want to know the shortest path between each node. The thing is that you can simply just add up each line, right? So you can find the shortest path to each node. The problem here is that a computer is not going to work as us, okay? You can see this without perspective. You can analyze it with your own eyes and say, okay, see, A to C and then B is shorter than just A to B, right? Yeah. It's not going to be in any specific order necessary.
It also depends on the algorithm. I don't know.
Dijkstra.
Actually, no extra, but it might take also into account the quantity of nodes that will go to. By nodes, I mean A, B, C, D, and E. So it may evaluate if going to A, C, B, E is less nodes than going to A, C, B, D, E.
So
Before,
it will depend on the algorithm.
yeah, before I show you the video, I need you to understand that a machine, a computer, is not going to see all this in this specific algorithm, but it's not going to see this completely and just analyze which one is the shortest path. It's going to do trial and error, okay? It's going to see, well, A to C is shorter, right? Then A to C to B is shorter than A to B, okay? That's what it's going to understand, okay? Then the computer will know that then B to D, I believe is 2, then it makes it 5. But 5, it's bigger than B to C, so it's going to go back to C. Okay? Sorry, it's going to go back to A to B because it's the shortest path. It's going to go to the shortest line that it's possibly can that haven't went now. Okay? Do you understand now?
So it runs through all possible permutations as long as it doesn't repeat a line.
Yeah, but it's going to go by paths. So it's going to go A to C, then C to B, and that's 3. But then any other path is going to be bigger than A to B. So it's going to go back to A and go A to B because it's the cheapest, let's say. It's the one that is less than any other. Okay?
So is it adding? So
Yeah.
when it's at B, it already has a value of 3.
No. If it goes back to A,
I know it, but it goes back to A when it's still at B.
yeah,
So at B, it holds the value of 3, and then it compares 2, 3, and 4.
so no, it's going to compare 4 and 3 to choose the path, the correct path.
Okay, so if it's going to compare 4 and 3, why would it choose 4 if 3 is smaller?
Let me show you the video. It's important to understand the way that computers.
Back to A, if 4 is bigger than 3 and 2, and 3
Okay, we'll come right from
How does the
where?
computer?
from B.
Okay, you're saying that. It's going
Because
to
he said
B
it
and
goes
then
from
goes
A
back.
to C, and then goes to B, and then it goes back to A.
On a weighted directed graph. Dijkstra's algorithm tells you the shortest distance from one node to every other node in the graph. This differs from prims and Kruskal's, which result in minimum spanning trees. Let's use the following graph for our example. We'll keep a list of unvisited nodes at the bottom. Our first step is to pick the starting node. Let's choose A. We'll use the table on the right to keep track of distances. Remember, the distances we are measuring are from our starting node, A. We put 0 for A and infinity for the others, as we haven't visited them yet. The next step is to examine the edges leaving A. We can reach B and C from A, so let's update the chart with the corresponding costs. Next, we look at the chart and pick the smallest edge of which the vertex hasn't been chosen, in this case, C. Let's cross off C in the unvisited node list, marking it as closed. After choosing C, we examine the edges leaving C and update the chart accordingly. B is now reachable from A with a cost of 3 by traveling through C. Also, D and E become reachable for the first time. Let's do the same thing as before, choosing the smallest path with an unclosed node. This time it's B. We repeat the process, examining the edges leaving B and updating the cost of getting to D and E. Now we choose D. This time there are no updates to our table, as there are no edges leaving D. Finally, we choose E. Again, there are no updates, but this time because the edge leaving E does not result in a shorter path. All the edges in the graph have now been visited and are closed. Here is the shortest path from A to the other nodes. The time complexity of Dijkstra's is big O of B.
Okay. This is the final result. Do you understand any questions? It's really hard, okay?
What happened to the D?
¿Ah? Ah, porque es más corto de B a D que de ahí.
Do you mind going back a little bit in the video and then pausing the image? Okay.
Okay,
So every time it reaches a new node, it reevaluates itself.
yeah,
It
That's-
updates the counter.
this is the track,
Distance.
okay? The thing is, this, as humans, we don't take note of this, okay? So it's going to go A to C, then C is gonna get reviewed as the new central node. It's going to update all these values. Then it's going to go to B, the shortest, because the shortest one, so it's going to update the values. Then it's going to have 3 as a value in B, but it's going to have A search for the new closest node that is the cheapest. Okay,
Wait.
open node.
So
She made a point that in your explanation,
Scroll down.
the arrow from D to E is pointing from D to E, but in his explanation is pointing from E to D.
That's why we told them.
Oh, yeah, sorry.
Yeah, there were two possible solutions for it. And
Yeah,
you also, so I assume that you have to take into consideration the direction for which you travel.
well, in this case, we have, like, to get to D, we have 3 possible considerations. So, yeah, I get it's wrong right there. But the thing is that you just need to evaluate.
Right, but when you were saying that you need to get to E, right, we were taking 2 possible values starting from B. Right, because you're at B, right? You can either go to B and then to D, that's 2, and then go down to E, and that's 1, so it's 3. Or you can go from B directly to E, and also equals 3. So you can take either path.
Yeah.
Oh, okay,
Where's the algorithm?
Takes into consideration how many nodes you visit.
yeah,
Right, which is the question that I had originally, and that answered it. But because we have a different image from what you were explaining, then that changes things, because in the image above, right, you only have one-way path, you go from E to D, not from D to E, then that changes things. The only way to get to E is directly from E.
right.
That in the diagram or, and if you put, there were 2 possible.
Yeah, I get it. Well, I'm sorry. Some mistake. Well, this is Dijkstra. Any questions about the function of Dijkstra?
what do we need this for? Why?
Okay, I was going to get to that just after this, but that's an excellent question. We care about this type of algorithms because if we're going to work on robots or mechanisms that requires some specific path, we're going to see at the last algorithm, we're going to see the A star algorithm. That is the most used algorithm to establish a path for any robotics. Okay? So, the long term, I want you to understand algorithms. I'm going to show you what is this algorithm that I'm talking about, A star. So, in some projects, the coming projects, you can have a little bit understanding of how algorithm works. So if we need to make a path for a robot, focus it on that, or any, let's say, directions that a path of a robot might need, we're going to go back to this.
For the robot plus, you know, with the side where you go. Right, or from that sold in, right?
They can think that anytime you're visiting a node, there are one way. Go back. Or in this example, the way that it's. So for example, from B to C, I can go from B to C, it has one value, but I can also go from C to B and it has a different value. Right, so they're basically one-way roads.
Yeah, but in this case, circle.
Right, but I'm not just talking about between B and C. Right, if I go from C to B, it has a value of 1. And then if I go from B to C, it has a value of 3. That's because they're not taking, in layman terms, they're not taking the same road. Okay, so is there a situation where it could go back and forth through the same road and still have the same value? Or would it always have a different value? Or would it be like 2 different roads that you can't potentially give the same value to? Or am I just getting ahead of myself and better just? be-
You're getting.
Yeah, I'm not sure about
I
the
think- Wait,
But I mean, it's not gonna go back. But always looking forward.
Well, some of them does, okay?
Okay, so I'm getting ahead of myself.
Yeah.
Yeah, how many steps ahead can you go? Like if you say,
No. There's not steps, there are nodes. And we're going to, in this specific algorithm, Dijkstra is going to evaluate the closest node that it's open, that hasn't been visited before. So it can establish the shortest path.
Okay, so once it's at B, it cannot go back to C. Or it would be able to because there is an open path despite it not being.
The thing is that it's good, when it gets to C, it's gonna write down the path of C. So if he goes to B and there is a longer path, let's say to E, in this case, it's going to stay with B, with the C path.
Oh, but technically, couldn't it just not go back because it's already visited?
It's not necessary to go back because this Dijkstra have memory. It remembers the path that have been.
So basically,
So if
it's
it's
forward.
visited, you can't go back.
I mean,
It depends. In this specific.
this is the question, but it's going to evaluate every path and my think of it as going again to the node.
Okay,
If you evaluate from C to E to D for some reason, and then you say, okay, it's gonna go back to C. No, it's not gonna go back to C. It's gonna evaluate the other path
I under,
possible
I
from C to the other nodes.
I understand your question. Okay. Dijkstra is not physically going back, as Adriana said. Yeah, not physically going back. It's just going to remember the path that already been
I
established.
mean, like you in code. You. Simple way.
so one question, since we're analyzing the shortest path from between each node, what happens if the next step after the first node is shorter than the other possibilities? For example, from A to C, what if it's 5, but then from C to E it's 0?
Okay,
Or like less steps, like less
Okay,
distance.
A to D,
Would be 5, for example,
5.
and then from C to E would be a shorter distance than what? What I'm trying to say,
No, I get it. And that's an excellent question. The thing here is that Dijkstra is not perfect,
okay,
okay? So it's going to get in general the shortest path to every node.
okay,
But in some path, let's say A to B, is technically longer than B to B. Let's say,
yeah.
it's going to take the shortest, okay?
Okay.
So it's not necessarily perfect.
I got it now.
The other question, answer. Meaning it's called, the way to represent it is having a function. And the function is the first one is gonna evaluate the path from C to E. And the other one is gonna evaluate the path from C to B to other nodes. But it's not physically going back. It's-
So it takes into consideration the value of what if it did go back, but it doesn't actually go back.
So instead of doing physical steps, it memorizes paths and then compares them to from past to present.
Exactly.
And then take the decision.
It's really
So it just evaluates all and choose the.
The thing is
So
that.
it like maps it out, maps out so it just
Yeah.
like when you see in movies that there's an unknown cave and then they send a robot that scans everything and you get the scan and it's like, okay, instead of walking for everything, take this one path.
Yeah.
Right, so it scans everything and then runs the numbers and evaluates the shortest path, and you go and then run that path.
Okay, this is going to be an activity. It is really important for you to learn how to search and understand better the algorithm. So I would let you choose, okay? I have two that they are like actually kinda easy, okay?
Easiest one.
Both are practically the same thing. Okay, we have the uniform cost search, okay? That is an algorithm you can find in Git for gigs that it's similar to Dijkstra, okay? But it's used to another application. And we have the greedy algorithm. Okay, the greedy is really used, okay? So I'm going to let you, please, everyone, take your phone, your laptop, whatever, and search either for the uniform cost algorithm or the greedy algorithm. Please, I need a unanimous vote. Please choose one. Which one do you prefer? Raise your hand for the greedy. Okay, no one? Okay, we're going to see the uniform cost search. Okay, please search it in gigs for gigs. Read it, and then I want you to all explain how does it work.
In the
Can we
end, we go for Dijkstra for large graphs.
Large.
Can we team up in groups?
Yeah.
How's it?
Uniform cost search for large graphs. Okay, large graphs. Don't go with AI. We're not going to get into that. Okay, I will give you, let's say, uh, 8 minutes. Yeah. Time. Okay. Now, who's going to be the first one? Please.
First one's here.
I mean, I'll explain.
You want? Okay, come here.
So,
Explain to us, anyone that has any inconvenience or thinks that something that he said is wrong, say it, okay?
please.
We are not going to participate in this one, okay? We're just going to, in the end, we're going to see if it's correct, okay? Please.
I'm going to make this very short and sweet for you all. I'm assuming that you've understood how the Dijkstra algorithm works. What I found by my searches is that the uniform cost algorithm is a extremely similar algorithm to the Dijkstra's, where the Dijkstra's, it starts with a root node and it finds the shortest possible path between any other node in this. So it could find the shortest path from A to B or the shortest path from A to B, right? Anything, or from even B to B, I guess. While the one, what was it called? Uniform cost algorithm. It has a node and it has a goal node. So let's say D in this case. It would do the Dijkstra's algorithm, but specifically to find the shortest distance between A and its goal. So that's all.
That's perfect. Dave, can I something up?
Yes, question.
That once you visit a node, you shouldn't go back. Or yeah, you're not allowed to go.
Same as in Dijkstra's.
Yes.
It's the same.
Yeah.
That was amazing.
Good job.
Amazing.
Yes, that was.
That was amazing. I'm really happy that you took your time and understand that one. Because we have here the code. Okay, wait. I mean,
Pay attention because we love them so much.
okay, do you see the code? Yeah. Okay. So you understood how the Dijkstra algorithm works and how the uniform cost search works, right? So now we have here the code. What does the code need to have so it can work? What will it be? Your pseudocode to make the algorithm.
You will need a starting point, right?
Yeah, as You said
a goal to.
the uniform
Destination.
code search needs and starting point and then the destination. So now we have that, right? We need to set destination and the endpoint. But we also need to have a map, right? We need to have this thing. We need to have the nodes, okay? The map. We have to define them in the map. We need to do each specific node and the value that each route takes to every node. So if we define our starting point and then our endpoint, we can say, okay, we have a map and then we have our specific paths. Okay.
When you're setting your code, are you setting it to create like a diagram, a map, or is it more of a, like a list where you can go through each of the parts of the list? Like, does that like, so you make coordinates? That's
Yeah.
what I'm saying. Okay.
Here we add the costs of each interaction from each and every single node. This code is not the one that you saw. This one is pretty simple. Okay? So we set the function, we create the edge, we create the graph. And here we set that the graph size is 7. Then we have here a loop. We saw that before, right? Last course. Yeah. So you know what a loop is. Well, the queue is not empty. Why the queue is not empty?
You know what a queue is?
A queue,
Queue is the data structure, and that means that it's gonna hold elements. So a list, difference is how elements go out and go. So queue usually something that's called first in, first out. That means that when, example, 5 goes in the list, 5 is gonna be the first one to go out. That means, so it uses pop, and the other one, what's the other one? Top.
So queue is like priority?
there's no push.
Yeah.
Yeah.
Push.
Yeah, there's push.
Top is placing an element as priority in top of the list. Pop is getting out,
Yeah.
popping out, and push is getting an element into the list.
So why? Check it this while. Okay. This is while the queue is not empty. Why do we need to know if the queue is empty?
Because it means that we haven't reached the destination, maybe?
If you want, I think you have this code too. Well, if you see, we need to establish at first, we go in line. We need to start making the graph. We're using vectors. Then the map to store the edges. Do you remember in the layout in the first class I told you was the second thing that you need to put in the layout? You have your includes and then you have your definitions. You have something that you need to define for your code, okay? Something that is going to be used along the code. In this section, we see that is the graph and the map, okay? So now, you see all these functionalities inside of this code. I don't really want you to understand everything, but I want you to take a look here. Please check the code. And if you know something, let's say anything. Let's say, I don't know, push, okay? What's push? What does push do in this queue? What does push do?
Is the queue number inside the queue?
Is that it's removing the last, yeah, that's,
Well, as a programmer, and I told you before we start this, you need to search. Okay, it's really important for you to learn how to search things. Because if you don't know something, you need to search it. You can't say, no, I can't do this. It's too difficult.
You can ask also.
Oh, it's the first.
Yeah, that's an excellent thing. Just ask ChatGPT.
I mean, I use it for.
Well, now we can run it. So the minimum cost from 0 to 6 is 3. Okay, so we set an end goal, we set a starting goal, and then here in the output, we get the minimum cost. Okay,
You have to. Graph.
the other one have it in graph. Okay, so now we're going to get to the big leagues. Okay, we're going to see the one that I wanted to show you, the beautiful A-star algorithm. You see here, but it takes a little bit of time. Okay, there you go. The A-star is a little bit different from the Dijkstra. You see here, I can show you how it's set. Okay, this is a big boys code. Okay, so here we have the list. We have everything set so you can see. So the path is 87654, etc. Okay? You have this code. You actually have it because I sent it to you. Now, for any complications, as I saw before, I'm going to show you a video, okay, about this specific algorithm.
Imagine that you're a mouse in a maze. You want to find the shortest path to the piece of cheese at the end of the maze in the fastest way possible. Well, you could search the entire maze exhaustively to find the cheese, but this would take way too long. Let's say that now you can smell the cheese. This is called a heuristic. The mouse kind of has an idea of which way to go towards the cheese. Sometimes the mouse goes off course, but it won't go too far off before realizing it's a mistake. You can model this maze as a graph and the sense of smell as a heuristic. As the mouse gets closer to the cheese, the smell gets stronger. At the beginning of the maze, the heuristic or smell indicates that the cheese will be closer if the mouse goes right, so the mouse will go that way. So the heuristic is allowing us to prioritize our options when multiple are presented to us, and it's giving us a rough estimate or an idea of how far we are from the goal. So if we prioritize the distance from the start state plus our heuristic, this gives us an estimate of the total path length. And our goal would be to minimize this total path length. Let's do an example. First, we add some distances to our graph. This represents how far the node.
Okay. Basically, you have heard what's an heuristic.
Being the farther away it's closer it gets stronger.
So this is what we discussed in the experiment. That's our way of like finding the shortest path.
It's our intuition.
Yeah, exactly. Because this specific algorithm has a little bit of intuition into it. The heuristic is the estimate from the starting point to the end point. How many nodes, how much the value is going to be. That's the heuristic. In this case, it's shown as a smell. Us humans, when we see some algorithm, we can maybe make a path in our mind. We don't need to actually draw it. We don't need to actually go one by one to get to the end point. We can set an estimate. We can say, well, maybe from here to here, let's say it's, I don't know, 25. Yeah, that could be a nice estimate. So let's say 25. Maybe it's not going to be exactly that, right? But it could be close. So that's the heuristic. Now we're going to keep seeing the video.
The algorithm uses a Euclidean formula. That's the formula are like our intuition is based on that formula. So that's calculated.
It's far from each other. Let's also add some heuristics. So we'll put the red starting node on our queue and give it a priority of 0 plus the heuristic value, which is the estimated distance to the cheese. We then pop the
Okay, we have two values. In this case, we have 0 plus 90, okay? Is the heuristic value. In this case, we are going to have two values to this formula. The formula, let's say F, is the total cost of the cell, okay? Of everything. Then we have G, that I'm going to say like the actual cost of the start cell to the current cell, okay? So let's say 90 to 85 is going to be the actual cost. Well, we know it costs, right? Then we're going to have the heuristic. So the formula is G plus H, the actual cost plus the estimate, okay? That's the formula we're gonna use because that's the core components of this specific algorithm. That's the cell structure that is going to follow that simple formula, okay? Now, if we can
this node off the queue and add on its children. Taking a look at the queue, we see that the node with a purple heuristic of 85 has the lowest priority value. The priority of 88 means that the estimated distance from the start node through this node to the cheese is 88. Since this is the lowest priority on the queue, we take the path along this node. So we pop it off and add its children. If we continue going this way, we'll search these parts of the graph shown in blue. This is way better than an exhaustive search like BFS. So again, a heuristic is like a sense, a hunch, or another way to perceive the world. The A-star algorithm harnesses the power of good heuristics to search less area and find your goal faster.
Okay. There's like a 12-minute video about this that we're not going to see. But you get some idea. We have some steps to do this A-star algorithm. We have the initialization that starts by verifying the source and destination, initializing cells, cost FGH for each cell. The cell exploration explores 8 possible directions: north, south, east, west, northeast, northwest, southeast, southwest. For each direction computes new F, G, and H values as the neighbor to the open list if a better path is found. Okay? Termination. The search stops when either the destination is found or no more cells can be explored. Okay? In this case, this algorithm is pretty useful, and we're going to use it to track and make paths within a specific robot. Okay? I made all of these courses based on the idea of the, what's it called, the robot? The lunar rover. Because we need to learn the basics of programming in Python, and then we need to learn how to program the path of the robot. And most of the code is going to be the movement of it. So this is the importance of the robot, and that's what we're going to see specifically in this course. That's why I made based on algorithms. I know it's a little bit difficult. I know at least you get the hang of Dijkstra, because to understand the A-star, you're gonna take at least 2 more hours to have that much of time.
And also the reason why we use C++ and not Python, for instance, performance.
So
Python doesn't work with a compiler, which is the way that C and C++ works. It's an interpreter, and that means that, I mean, I think you saw in Python when you declare a variable, you don't have to say if it's an integer or a string.
Yeah.
That's also part of the effect on performance. It's not good. That's why we use C++. And we need to define, okay, is this an integer, is this a string, is this a float, which is decimal, or any data structure.
That's why I put so much focus on you expressing what your input is going to be in the practice that we did, because it's really important for you to understand that we need to specify everything. And in this case, C++ is not just for performance. It's because when we are working in Arduinos or mechanical base programming, we're going to use C or C++ in this case. Questions? No?
And also, if you want to understand really how it works, I recommend some topics. And that will be data structures, specifically linked lists and trees, but that's part of linked lists. Also memory management, which is related to data structures. And basically the syntax of C++, which is really different in Python. That is very useful.
I know you all are tired, and I know this crash course was really different from the first one.
It's not a crash course.
Yeah, this is like an cult, okay?
But a strong word to use.
But I know it's really difficult. And I know it's really hard to see this, and maybe you don't understand all of it. Let me tell you that some parts of this code, I have to look it up to understand what does they do, okay? Because they are really complicated. Now, I know this course took a little bit too long, but I want you, if you can, take out your laptops, if you have CLI installed, please search any algorithm you want, and add it, make a new project in C++, in CLI, it's the same thing as PyCharm. And if you want, you can write it down. I don't know, it might not work, or copy and paste any algorithm you find online. So you can maybe understand a little bit how it does just add something to your files made. How does that work? Okay.
Yeah, then you gave me an idea for one of the projects that we wanted to do. Remember the Einstein shapes?
Yeah.
With the shapes, we can just use an algorithm, right? Could to like find out more shapes.
Oh, yeah,
Yeah,
yeah.
that would be like an application.
Actually, that might be like a loop.
Just an iteration.
Okay, also, all algorithms work based on loops. Okay, do you
Okay.
see the while that I showed you before? Yeah, because all algorithms, I forgot that. All algorithms are based on loops. So every algorithm that you might see are looping all and all over again to keep on going to search for the best path. Okay. Most algorithms function in a way that we may think that it's not correct, okay? Most of them go point A to point B, then point B to point C, then start all over again and go point, let's say, I don't know, X, point W, anything. The way that it works normally is not completely structured. The only way you can control an algorithm and make sure how does it going to work is if you set the map yourself. Okay? Or you study the map and know a little bit of how the algorithm is going to work. That's why I make emphasis in the start that you need to know the input and the output. When you put an algorithm, you normally are going to know what's going to come out of it. Okay? Because you need to know how the algorithm works. What are you putting in and what's coming in?
So you tell me one flaw in the Dijkstra algorithm was that if all the distances were the same, it would go through all the nodes. So will you be able to modify the algorithm or like implement another algorithm as a backup to when that
This one, they started the solution for a fail that the Dijkstra algorithm has. Okay, if all of these nodes are united by a value of 1, and all of the nodes are connected. Okay, let's say this thing. Okay, and all of this is 1. I'm not going to write it all, but if this is the Dijkstra algorithm and all the values are 1, you connect it like this too. So it's like an open map, right?
Yeah.
The Dijkstra algorithm is going to eat them all. It's going to go all over the map completely, because if all the values are 1, it means that the shortest value is going to be 1. And if you start from for any node,
So that's where the heuristic comes in, like the intuition.
yeah, that's why the intuition is going to work so good for these problems, because if this is the stuff going through all nodes and wasting a lot of time and not working correctly. Imagine if that's our robot. Our robot is going to start here and is going to go here, 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 here until it comes here, right? That's inefficient. That's not what we want. We want it to go like this, or even go like this. Okay? That's what we want. We want functionality. We want something that works, something that can be used. This case is this one. We normally don't use Dijkstra or anything else than math or numbers, number computation. Okay, but this one is actually used in physical objects. That's why I make emphasis on this one. That's why if you have time, want to learn a little bit more to help the club, you should go and read this one in a specific. Now, I know it's a little bit tedious, but I need to make this question, and I think it's very important. Because our plan here is not just to show you and teach you a little bit of basics about programming, in this case C++, is for you to choose what's going to be your focus on this club. And if you're part of the club, I want you to know that we're probably going to have sections in each of our projects. We have the investigation and the research, yeah. Research section, we're probably going to have the mechanic section that is going to be managed by Ignacio, that he was.
Yeah, it's gonna be stratified by like each officer, and each officer is gonna have their own team, basically.
Yeah, exactly. So the next course are probably going to be some other about research, I think.
It's gonna be time for natural.
Yeah,
engineering,
Exactly.
modeling, and design. And we're gonna talk about space mission protocols. So if you wanna see that more in depth, come join us on Friday.
We're going to see that, then we're going to see some circuits, okay? Some connections. I don't know how to say them in Spanish, sorry in English, but yeah, we're going to see that. So I want you to start thinking about which one of the groups you want to be part of. Well, I imagine that you assume that I'm going to be the person in charge of the programming section of the project. That's true. So if we're going to do it that way, I'm probably going to teach you a lot more about programming. I hope I can, because this is really interesting, and I hope maybe some of the people that were here liked. But yeah, so if you want to be part of the programming section, just hit me up. I'll tell Manfred. So for the projects, we're probably going to see a lot of this algorithms, a lot of algorithms. And some controllers, that the controllers are actually really simple to make. Okay? The controllers are really simple to make. Working with Arduinos are really simple. That's why I chose to teach you about algorithms, to take the worst part first, right? To show you the most problematic section of programming. So, yeah, I think that's it. Do you have any questions? Any advices that you may want for this code? Or anything about programming, maybe from the class before, maybe for this one? No? No? Okay. Well, then, thank you.